In July 1887, on the Champ de Mars in Paris, 4 iron legs were rising out of the ground at once, each built separately, each already several stories tall. Riveters worked on narrow wooden platforms more than 30 meters up, with no harnesses and no floor beneath the scaffolding. Their job was singular and unforgiving: bring all 4 legs together perfectly at 1.57 meters in the air. If the alignment drifted by more than a few centimeters at that height, correcting it afterward would be extraordinarily difficult. There was no redesigning it afterward. There was only getting it right the first time. The tower was meant to be the centerpiece of the 1889 World's Fair, marking 100 years since the French Revolution. The French government wanted a monument that would prove French engineering could outbuild the rest of the world. But iron, at the time, was still viewed with suspicion for anything this tall. Wrought iron, not the steel that would later rise over Manhattan. Nearly 2.5 million rivets would hold the entire tower together, and roughly a third of them would have to be driven by hand, on site, hundreds of feet above the ground. The question hanging over the project was unforgiving. Could thousands of pieces, each designed and drilled months earlier at a drafting table, actually fit together on site, on the first try, with no room to cut, re-drill or improvise once they left the ground? Running the assembly on site was Jean Compagnon, a veteran carpenter and bridge builder who had spent 2 decades erecting bridges and viaducts across Europe, in Portugal, Hungary, Russia and the mountains of central France. Eiffel's firm brought him in specifically because he knew how iron behaved under load, at height, in bad weather. A foreman with that kind of experience relied on more than drawings and gauges. He would have judged whether a joint had seated properly by the sound of a struck rivet, a clean ring meaning a tight fit, a duller thud meaning trouble. It was a skill built not in a classroom, but across 2 decades of scaffolding throughout Europe. The precision began long before anyone reached the site. At the company's workshop in Levallois-Perret, engineers and draftsmen produced more than 5,000 detailed drawings for 18,038 individual iron pieces. Engineer Maurice Koechlin, who had sketched the tower's original concept, personally authorized every single piece before it left the workshop. Each one was machined to an accuracy of 1/10 of a millimeter, with rivet holes positioned to within 1 millimeter and angles calculated to within 1 second of arc, because none of it could be corrected once it reached the sky. About 2/3 of the tower's rivets were driven inside the workshop, under controlled conditions, before the pieces were ever shipped. The remaining third, roughly 800,000 rivets, had to be driven by hand, on site, by teams of 4. One man heated the rivet in a portable forge until it glowed. A second held it in the pre-drilled hole. A third shaped the head. A fourth swung the hammer. If the metal cooled before the head was fully formed, the joint would loosen instead of tightening as it contracted, and the entire rivet would have to be cut out and replaced. To bring the 4 legs together at the first platform, workers used sandboxes and hydraulic jacks at the base of each pier. The jacks were adjusted gradually, by hand pump. Millimeter by millimeter, each leg tilted into position. The gap closed. The beams met. Compagnon's teams drove the connecting rivets soon after, before anything could shift out of place. What had been 4 separate towers became one structure, 57 meters above Paris. Above the first platform, the work only grew harder. Every level narrowed, every angle changed, and riveters now worked overhead as often as at eye level, bracing themselves against the tower's characteristic curve, a shape Koechlin and Nouguet had calculated specifically to resist wind pressure. The higher the crews climbed, the more the diagonal lattice bracing multiplied, each piece cut to a slightly different angle than the one below it. Very few pieces above the first platform were identical. Every joint was its own puzzle piece, already assigned its precise place months earlier, at a drafting table in Levallois-Perret. While the frame climbed, the controversy climbed with it. In February 1887, 47 prominent artists and writers published a public letter condemning the tower as a monstrosity, warning it would disfigure the city forever. Construction did not stop. By the time the protest reached print, the foundations were already poured and the first iron was already being cut in the workshop. The people building the tower had no time to answer their critics. They only had a fair opening date and a frame that still had to reach 300 meters. The tower was completed in 2 years, 2 months, and 5 days. A pace almost no one believed possible when the artist's letter was published. Official records attribute only a single fatal construction accident to the project, a remarkably low toll for the era. Eiffel had insisted on guardrails, movable scaffolding, screens, and an on-site medical post, and the precision built into every piece back at the workshop meant the crews on site rarely had to improvise a fix at height, which left far less room for a fatal mistake. The tower was never meant to be permanent. It was built as an entrance arch for a 6-month fair, a demonstration of French industrial confidence timed to the centenary of a revolution. It was iron proving what iron could do, not for a corporation's ledger or a landlord's rent roll, as skyscrapers across the Atlantic soon would be, but for a nation's public showcase of what its engineers were now capable of building. Eiffel's concession to operate the tower was due to expire in 1909, after which the city of Paris could tear it down, exactly as planned. Eiffel saved it by turning it into a scientific instrument, mounting antennas for the new technology of radiotelegraphy, giving the tower a use the city no longer wanted to lose. It held the title of tallest structure in the world for 41 years, until 1930, when the Chrysler Building in New York, riveted together the same way, though built of steel rather than wrought iron, finally passed it. Every rivet in the Eiffel Tower had already been decided before it left the workshop, its size, its angle, its exact position in the frame, because nothing at that height could be left to chance. The men who drove those rivets by hand, hundreds of feet above Paris, were executing a plan drawn years in advance, one piece at a time. What looks today like a monument to French elegance was, underneath the ironwork, a monument to something less romantic and more exacting: the discipline of getting 2.5 million small decisions right, one at a time. The Eiffel Tower still stands more than a century after its 20-year permit expired, held up by rivets nobody expected to matter this much. If you'd like to see more of these forgotten engineering feats preserved, consider subscribing. And tell us, which iconic structure should we look at next?